G'day chemistry students, we're continuing 3.1.3 in part 2 of our types of chemical reactions video. In this one we're going to be looking at a few different kinds of neutralization. Let's get into it. So first off, if we are neutralizing, the idea is that we are putting an acid and a base together, and when they do so, they neutralize each other. The acidic and basic components no longer exist, their properties no longer pronounced, and essentially they form some sort of neutral or near neutral salt and a lot of water as well. So that's our general equation. Acid plus base leads to the formation of a salt, which is certainly closer to neutral than the original acid and base were, and an amount of water as well. A bit more of a pictorial version showing what sort of happens in the reaction as it progresses. So, for example, here we have sodium hydroxide and hydrochloric acid reacting to form sodium chloride. So our sodium atoms don't really change at all. Our chlorine atoms don't really change at all. But the hydroxide atoms and the hydrogen atoms come together to form excess water in this neutralization process. I have a couple of other neutralization examples here down the bottom. What you'll notice is that the hydrogen component of the acid and the hydroxide component of the base form the water, and the other anion and cation, the chlorine and the sodium in this example, form sodium chloride, or in this example down the bottom, the nitrate and the potassium component form potassium nitrate, and that's the parts that form the salt. Now there are some other example of acid-base reactions, other neutralization reactions, such as the one here. Here we have hydrochloric acid and ammonia forming ammonium chloride. Now what you'll notice is that there is no water formation. There are other examples of neutralization that don't follow this general equation up here. Acid plus base forms salt and water. In particular, what you'll notice is that there is no oxygen present to form water at all. We're not going to be focusing on these reactions really at all in this topic, but something that we'll delve deeper into during Module 6. There is another subtype of acid-base reaction that I want to focus on as well, which doesn't exactly follow our main general equation up here. This is a special form of neutralization reaction between an acid and the base, but in particular a carbonate base. So when we react an acid and a metal carbonate together, they form salt and water just like the general reaction that we saw previously, but it also forms carbon dioxide as a third product. And here I have an example showing roughly the same thing. So we have the zinc and the nitrate that don't really participate in the formation of the other byproducts, but just the salt. So they just form the salt as per usual. The hydrogen as a part of the nitric acid forms water, but not all of the oxygen in the carbonate does so as well. So most of the oxygen will just form carbon dioxide gas, and the excess oxygen is there to form the water too. What I want to talk about as well, when we're going to be doing some practical work around these neutralization reactions, there are ways to measure or detect that the reaction that you've actually done is a neutralization reaction. Now, that is mostly through measuring pH. You've probably seen a pH scale similar to this, maybe a color scale that would be similar to universal indicator, which will give you a fair description by color of how acidic or alkaline, also known as basic, your substance is. So for example, if you put the indicator in an acid and add some base, maybe you'll see it progress towards neutral, and by adding additional base, you may even see it progress into these blue or purple colors. Now, there are some other ways of measuring pH. You may have something like litmus paper, which just simply tells you if there's an acid or a base present. There are other indicators that change at other pH ranges too, something that we'll look at a lot more in Module 6. We also have digital pH meters that we can be using as well, which give much more accurate representations of pH compared to these, what I would call more qualitative versions of measuring pH. We also have the ability to detect the presence of carbon dioxide if we were doing an acid carbonate reaction as well. So if we were able to bubble the gas that we were producing when we were doing an acid carbonate reaction, we could bubble it into some lime water. Now, lime water is calcium hydroxide, and in the presence of carbon dioxide, if we bubble it through, it will end up forming calcium carbonate, which is not soluble in water. So it starts as a solution and forms this white precipitate here that's not soluble soluble. It also makes excess water, which we can't really detect, but we can certainly see the production of solid calcium carbonate, and it makes a milky white suspension. So we might actually do that as well when we are doing our practical activities too. Thank you very much, everybody. That concludes today's tutorial video. In the next video, we're going to be looking at part 3, which is all about precipitation reactions, actually building on some of the concepts which I just talked about with lime water. But until then, have a good one.